Here I'm going to look at 3 examples, one dealing with triangles, one with trapezoids, and one with rhombis, and dealing with the areas of those figures. My first one, I want to calculate the area of this triangle. Well, for starters, I'm going to think back to my area formula, and that area equals 1/2 times the base times the height. So I have to find my base and my height in my triangle. Well, the first thing I notice is this is a 30, 60, 90 triangle. So I have to remember those properties of a 30, 60, 90 triangle. I notice that I have the hypotenuse, which is 12 root 3 centimeters, and the first thing I'm going to do then is I'm going to find the length of the short leg in my 30, 60, 90 triangle. I remember all I had to do was take that hypotenuse and divide it by 2. Well, 12 root 3 divided by 2 is 6 root 3. So this side of my 30, 60, 90 triangle is 6 root 3. And then to go from the short leg to the long leg, I remembered I needed to multiply by root 3. So if I take my short leg, which is 6 root 3, and I multiply it by root 3, this part right here is equal to 3, and 6 times 3 is 18. So the long leg of my 30, 60, 90 triangle is 18 centimeters. Well, now I can take that information and I can plug it in. I can let this be the base, I can let this be the height, and I can find the area of my triangle to be 1/2 times the base times the height. If I multiply that all together, I'll find my answer. Now what I'm going to do is I'm going to do some simplifying first, and I don't even have to use a calculator. This 2 is going to become a 1, and this 18 will become a 9. Now all I have is 9 times 6, which is 54, and then times root 3. So the area of my triangle is 54 root 3 centimeters squared. Now if you want an approximate answer, that's going to be a little different. So if we take 54 and multiply it by the square root of 3 on our calculators, now we're going to get an approximate value of 93.53 centimeters squared. So depending on what answer the problem is asking for, I have them both, exact and approximate. Now my next one is going to deal with a trapezoid. And now notice in this one, it wants us to calculate or find the height of the trapezoid. And notice it gives us the area. We have an area of 120 square feet, and we know the length of these two bases. Well, I think back to the area of a trapezoid is equal to 1/2 times the quantity of base 1 plus base 2 times the height. Remembering my formula. Now, I think about this, and all I have to do is plug in what I know. It told me in the problem that the area is 120 square feet. I'm going to plug that into the A, into my formula, equals, well, 1/2. Base 1, I see, is 10 feet, and it really doesn't matter which one is which. I don't know why I made that so small. Plus the length of base 2, which is going to be 20, and then times my height. I don't know that. So there's the one variable. I have an equation as one variable. Now it's just a matter of solving. So I'm going to have 120 equal to 1/2 times 30 times h. Well, 30 times 1/2 is 15, so I have 15h equal to 120. If I divide both sides by 15, I find out that my height is equal to 8. If I did my math right. Now, is there a label? Come up here, notice it was in feet, area was square feet, therefore my height is going to be 8 feet. So I used my area formula in a little different way, plugged in what I knew, and solved for what I didn't know. And here's my last one. Now I have a rhombus. This one's going to deal with a rhombus, and I want to find the area and the perimeter if I know the diagonal lengths are 6 feet and 8 feet. So what I like to do is just let's just draw a picture of this thing, what it might look like. It's going to look something like that. And it tells me that one of these lengths, will go like this one's 8, that's 8 feet, and then this one is 6 feet. So it wants the area and the perimeter. Well, I'm going to do the area first because I look at this and go, well, I already have the 2 diagonal lengths, so all I have to do is do area equals 1/2 diagonal 1, which is 8, times diagonal 2, which is 6. And when I multiply that all together, I'm going to find out that the area of my rhombus is 24 square feet. Area is complete. Now it's just a matter of finding the perimeter. Now remember, perimeter is the distance around. So what I'm going to need to do is I'm going to need to figure out how long are the 4 sides of my rhombus. Remember, it's a rhombus, so all 4 sides are congruent. If I could find just one of them, I'd have them all. Now this goes back again to properties of the diagonals in a rhombus. 1, I know they're perpendicular, and 2, it's a parallelogram, so I know the diagonals are going to bisect each other. Which then tells me that half of that diagonal is going to be 3, and half of this diagonal is going to be 4. Now I have a right triangle. And I'll show you that right triangle right here. I have a right triangle, I know 2 sides of it. I can find the 3rd side using the Pythagorean theorem. I'm going to do a squared plus b squared equal to c squared. So a, oops, didn't want to use it. It's going to make this color coordinated. So I'd have my a squared plus, then I'm going to have my b, which is 4 squared, and then that's going to equal the hypotenuse of my triangle, which is going to be c, which is one of the sides of my rhombus. Solve this little equation, and I'm going to know the length of each side. So this is going to be 9 plus 16. Add those together, I get 25. So 25 is equal to c squared. I take the square root of both sides. I get c equal to, and remember I have to take the positive and the negative anytime I take the square root in the equation. But being this is a rhombus, or a figure, it's not going to make any sense that one of the sides is less than 0, so this is going to have to be 5. Well, then if I want to come down here and calculate my perimeter, I'm just going to take that length of 5. I could add 5 4 times, or I could just do multiplication. There's 4 sides. Therefore, the perimeter is going to be 20 centimeters. So a little bit with the formula of area, and also a little bit of old or prior knowledge. You're going to have to use the Pythagorean theorem and those properties of a rhombus and a parallelogram. And that's going to conclude my lesson on, or my examples dealing with areas of my triangle, trapezoid, and rhombus.